Hello and welcome to the course Object-Oriented Programming using Java. Myself, Mrs. Shayami Chandra. I am an assistant professor of the Department of Computer Science and Engineering of Guru Nanak Institute of Technology. I'll be the instructor for the whole course of Object-Oriented Programming using Java. So let's go into the details of this course. So as I have already told that the course name is Object Oriented Programming using Java. The course code is CS504A. Total contact hours is 36 and credits allotted is 3. So these are the prerequisites. As you can see that you have to know computer fundamentals. You have to have some knowledge of computer fundamentals. You have to have some basic understandings of computer programming and related programming paradigms. You have to know some problem solving techniques with proper logic implementation. Basic computer memory architecture with data accession knowledge is also required. So these are the prerequisites of this subject. Now let's go to the course outcomes. As you can see that there are 5 outcomes. The first one, CO1, that says that design the process of interaction between objects, classes and methods with respect to object-oriented programming. So in the first course outcome, objects, classes and methods with respect to object-oriented programming are there. In the second course outcome, it says that acquire a basic knowledge of object orientation with different properties as well as different features of Java. CO3 is analyze various activities of different string handling functions with various IO operations. CO4 is discuss basic code reusability feature with respect to inheritance, package and interface. CO5 is implement exception handling, multi-threading and applet programming in concept in Java. So now let's go to the next slide. The next slide gives you the course contents. As you can see that there are 5 modules. In this slide there are only 3 modules mentioned, where module 1 has 5 lectures allotted, module 2 has 9 lectures allotted and module 3 has 4 lectures allotted. In the next slide you will get to see 2 more modules, module 4 and module 5, where 8 lectures are allotted to module 4 and 10 lectures are allotted to module 5. Next, some recommended books are mentioned. The first book, Java the Complete Reference by Herbert Shield, can be considered as the main textbook because most of the syllabus that is mentioned here will be covered from this book. And another book is Programming with Java, a Primer by E. Balagurusamy. You can also consider this book as a reference book. You can also take help from this book. This is also a very good book. Next is the lesson plan. I have prepared the lesson plan here. As you can see, the lesson plan is prepared syllabus wise, and in each lecture how much topic will be covered is mentioned in each row. So this is the lesson plan that I will be following. So the next page is the continuation of the lesson plan. So there are total 36 lectures allotted and I have divided the lesson plan in all these 36 lectures. And here in the last column you can see the number of lectures, and adding them you can get 36. So let's start today's lecture, which is the first lecture of this course. These are the contents that I'll be covering today: object-oriented analysis and design, object model, concepts of object-oriented programming language, class and object. So let's first start with object-oriented analysis and design. So let us first understand what is object-oriented analysis and design, or OOAD. It is basically a technical approach for analyzing and designing an application, system, or business by applying object oriented programming as well as using visual modeling throughout the software development process. That means, suppose we are developing a software. If we are developing a software, the first phase for software development lifecycle is the requirement analysis phase. So that is the phase which is known as object oriented analysis phase in our case. The next phase is here the object oriented design phase. So combining both object oriented analysis and design, so this approach will actually be used in order to develop the software. And in order to develop the software, we will be applying the object oriented programming techniques as well as the visual modeling also. This visual modeling is also known as object model, which we will be discussing in the later half of today's lecture. So let's now discuss the two parts separately, that is object oriented analysis and design part. The first part is object oriented analysis or OOA. As you can see that this definition has been given by Grady Bush. He said that object-oriented analysis is a method of analysis that examines requirements from the perspective of the classes and objects found in the vocabulary of the problem domain. So, what is basically object oriented analysis? We can say that object oriented analysis or OOA is the procedure of identifying software engineering requirements and developing software specifications in terms of software systems object model. And this object model in turn comprises of interacting objects. So basically this object oriented analysis phase will give you the requirements for developing a new software. Now it may come to your mind that what is the main difference between object oriented analysis and other forms of normal analysis techniques. The main difference is that in object oriented approach, requirements are organized around objects. So as we are dealing with object oriented approach, so we will be dealing with the objects only. Now these objects will be integrating both data and functions. That means inside the objects, data and functions or methods as we call them in object oriented programming language, both of them will be integrated. And these objects are modeled after real world objects that the system interacts with. So this is the concept of object oriented analysis. Now let's move on to object oriented design or OOD. As you can see on the slide, this definition has been given by Grady Bush again. He said that this object oriented design or OOD is a method of design encompassing the process of object-oriented decomposition and a notation for depicting both logical and physical as well as static and dynamic models of the system under design. So, what is basically object-oriented design is that it actually involves implementation of the conceptual model produced during the object-oriented analysis. So, in the object-oriented analysis phase, after analyzing the requirements for the software developing process, we have developed some models, and this object-oriented design phase involves the implementation of those conceptual models that have been produced during object-oriented analysis phase. So in this phase, concepts in the analysis model which are technology independent are mapped onto implementing classes, constraints are identified and interfaces are designed, resulting in a model for the solution domain. That is a detailed description of how the system is to be built on concrete technologies. So basically, this object oriented design phase will build will give you a solution domain, or it will give you another model that will be built on concrete technologies. So next let's go on to the details of object oriented programming or OOP. So Grady Bush has again given the definition of object-oriented programming, and he said that object-oriented programming or OOP, it is a method of implementation in which programs are organized as cooperative collections of objects, each of which represents an instance of some class and whose classes are all members of a hierarchy of classes united via inheritance relationships. So object oriented programming or OOP, we can say that it is a programming paradigm based upon objects. And these objects in turn have both data and methods. This object oriented programming or OOP aims to incorporate the advantages of modularity and reusability. Objects, which are basically instances of classes, they are used to interact with one another to design applications and computer programs. Now, the question may come to your mind that how object oriented analysis or OOA, object oriented design or OOD, and object oriented programming or OOP are related. How all these three are related? So let's look into it. We can say that the products of object oriented analysis that serve as the models from which we may start an object oriented design, that I have already told. Now, the products of the object oriented design can then be used as blueprints for completely implementing a system or a software using object oriented programming methods. So, there is a very simple relation between OOA and OOD and OOP. So, OOA basically will give you a model on which we will start designing. Then, OOD will give you the some products which can be used as blueprints to develop a software or a system using object oriented programming methods or languages. The next concept is object model. I have mentioned this term various times during the presentation, that is object model. Now, what object model actually is? Object model actually visualizes the elements in a software application in terms of objects. So, every element of the software applications, the softwares or the systems that are needed to be developed, every element of that software can be visualized as an object model. As we are using object oriented approach, so every element of that software application should be visualized in terms of objects. Now, I have mentioned the term object various times, so let us go into the detail of class and object. Now, class and object, these two concepts are very important concepts of object oriented programming language. So, let's learn what class and objects really are. We can say that object is a real world element in an object oriented environment that may have physical or a conceptual existence. So, basically, objects are physical or logical entity, we can say. For example, as you can see in this slide, student. Normally a student may have roll numbers. A particular student will always attend some classes. They will be attending some labs. They will be doing all the student related activities. Now, when we see these students, we actually see these student objects. Basically, all these behaviors of the student class should always be contained in each of the students present in the class. So, when we will see these students, we will actually see each individual student in the class. So, as you can see here, three student names are mentioned: Harry, John, and Smith. When we will go to the class, we can see only these students who will be present in the class. That means the physical entities that we can visualize are Harry, John, and Smith. So these three students are three objects of the student class. These three students should always have the properties of the student class. Like the properties of a student class, like a student should always have a roll number, a university registration number. A student should always attend classes, labs, seminars. They should go to industrial visits. They should be giving exams and so on. All these are the properties of student class, and we can see all these properties are also contained in these three student objects, Harry, John, and Smith. So basically, Harry, John, and Smith, these three are student class objects, whereas student itself is a class. Now, let's take some other examples. As we can see in the left hand side that there is a class called car. We know that a car has many properties, like a car has four wheels, a car has a steering, a gearbox, an engine number, a chassis number, and so on. Next, we can see the objects of the car class. We can see a Mercedes car, we can see a BMW car, then we can see an Audi car. So these three cars are the objects of the car class because these three cars also have the properties that a car class should have. Like all these three cars also have wheels, a steering, a gearbox, an engine number, a chassis number, and so on. So we can say that these three cars are the objects and this car is the class. So these three cars, Mercedes car, BMW car and Audi car are the three objects of the car class. Similarly, if you see in the right hand side, you can see there are three types of dogs. So normally when we see a dog, a set of dogs can be called a class dog. Normally, a dog class can have several properties like a dog can bark, a dog can wag his or her tail, a dog can run. All these properties are also there in all these three dogs. But we can see these dogs, which are Spot, Rover, and Rex. These three are the instances or the objects of the dog class. So we can see only the particular dogs only. That means the physical existence of the dogs that we can visualize are of the dog objects. And all these three dogs should always have the properties of the dog class. So we can say that a class represents a collection of objects having same characteristic properties that exhibit common behavior. It gives the blueprint or description of the objects that can be created from it. As we can see that here in the car class, all the properties of the car class are also there in all these three objects of the car class. And we can say that this car class is giving us a blueprint or the description of the objects that have been created from this car class. Here, these three objects have been created from this car class. So this car class is actually giving us the blueprint or the description of these three objects. And these three objects have been created from this car class. Creation of an object as a member of a class is called instantiation. Thus, we can say that object is an instance of a class. So, up to this, we have learned that objects can always be created from a class. And the process of creating an object from a class is known as instantiation. And this is the reason why we call objects are instances of a class. Now we can say that objects can be modeled according to the needs of the application. An object may have a physical existence, like you can see that a car. These cars have physical existence. We can see the cars, we can visualize them. Similarly, these dogs, they also have physical existence. We can see the dogs with our own eyes. Similarly, an object can also have conceptual existence, like a project or a process that we cannot see, we can just have the concept of it. So, if we consider the real world, we can find that many objects around us, like cars, dogs, humans, etc., all these are objects. All these objects have a state and a behavior. Now, if we consider a dog, then its state is name, breed, color, and the behavior is barking, wagging the tail, and running. If you compare the software object with a real world object, they also have similar characteristics. How? Because software objects also have a state and a behavior. A software object state is stored in the fields and the behavior is shown via methods. Now let's go to the details of objects. Now we have learned classes and objects. So let's learn some properties of the objects. Every object that we will be using in object-oriented programming language will have the following properties. The first property is identity. The next property is state. And the third property is behavior. Suppose let's consider a real world object as a lamp. Every lamp has an identity. What is the identity of each lamp that we normally use in our homes? Every lamp has a manufacturing code or a unique ID associated with it. This ID should always differ from lamp to lamp. So that manufacturing ID or the code is the identity of the lamp. Next is the state. What is the state of a lamp? A lamp can be in on state or it can be in off state. So the state of the lamp can be divided into two categories, on state and off state. The behavior of the lamp. When the lamp is in on state, it will emit light. When the lamp is in off state, it will not emit any light. So in the on state, the lamp will emit light. So its behavior is emitting light in on state. And when it is in off state, it will not emit any light. So in off state, the lamp's behavior is not emitting any light. That means the behavior always depends on the state of the object. So these three are the properties of the object. So as we have learned the concepts of class and object, we have already understood that basically what we can see with our eyes, we can visualize only the objects. We can never see the classes. As you have seen in the previous example that the student is a class, but we cannot visualize the student class. We can only visualize the objects of the student class, that is Harry, John and Smith. We can only visualize these three objects. We can never visualize the students. Similarly, in the next examples, car is a class, but we cannot visualize the car class. We can only visualize the objects of the car class. Similarly, in the next example, we can only visualize the objects of the dog class. We can never visualize the dog class itself. So the concept of the class and object says that the class will give you a blueprint or a description of what will be the properties that the objects should abide by, and the objects should always be instantiated from a class, and all the objects instantiated from a particular class should always have the properties of that particular class. An object of a class can not have the properties of another class. So this is the distinguishing property that we can use between objects. In order to distinguish between two objects, we can use this property, because a particular object should always be of a particular class, and an object of a particular class should have the properties of a particular of that class. It cannot have the properties of another class. So this is how we can differentiate between objects of different classes. So we can conclude that a class is a logical construct and an object has physical reality, because we can only visualize the objects, we cannot see the class. So basically the class will give us the blueprint or the description or the idea. That's why class is known as a logical construct, whereas objects can be visualized. We can see the objects with our own eyes. That's why we can say that objects have physical reality. So in the next lecture, we will go into the details of the object model that we have already discussed somewhat in this lecture.